In this video, we are learning how to connect multiple resistors into a circuit. There are two ways to connect two or more resistors to the same battery. We're going to call one of them a series circuit, the other a parallel circuit. A series circuit means that the same current runs through all the resistors that are in the circuit. Keyword here is same current. You can connect a series circuit simply by connecting the battery to one light bulb or resistor, connecting that one to the second light bulb or resistor, and then completing the circuit back to the battery. Draw a circuit diagram. It will look something like this. Notice that there's only one loop or one path or one circuit for the charges to follow. Again, they have the same current, which means that they have to have different voltages. The voltage across each resistor is not the same as the voltage of the battery. So for instance, if the first resistor has 2 amperes of current running through it, the second one has to have 2 amperes of current running through it as well. If the battery voltage is 10 volts, that voltage is going to be split between the two resistors. How exactly it gets split depends on the two resistors themselves. So in this case, the one on the left is 4 volts, the one on the right is 6 volts, for a total of 10 volts of energy loss as we go through those two resistors. Defining something called the equivalent resistance, or Req, is the total resistance of a network of resistors. So if you have a 6 ohm resistor and a 12 ohm resistor connected in series with each other, that's equivalent to one 18 ohm resistor. Find the equivalent resistance when they're in series, you just add up the resistances. Resistors that are in series do affect each other. If you disconnect one of the resistors, it's going to make them all stop carrying current. If you ever had some cheap Christmas lights where one broken bulb makes the whole strand go bad, those light bulbs were in series with each other. When you add more resistors in series, that causes the equivalent resistance to increase. This is going to have the effect of decreasing the current. To calculate the current, we're going to first always find the equivalent resistance of the series circuit. And again, to find the equivalent resistance, you just add them all up. Real simple. So for example, let's suppose we have a circuit and I ask you to find the current through each resistor and the power dissipated by each resistor. So here's the circuit that we're going to use. I have a 6 ohm and a 12 ohm resistor connected in series with a 9 volt battery. Finding the current first, when they're in series, we have to remember that they have the same current. And so when I use Ohm's law, solve it for the current, it would be V over R. The R that you need to use is the equivalent resistance. Not the 6, not the 12, but we use the 18 ohms. So the battery voltage divided by 18 ohms will give us 0.5 amperes. And so I'm going to label that there, showing that each resistor has 0.5 amperes of current running through it. To find the power, we have to realize that each resistor has a different voltage. Well, a shortcut. Instead of using the P equals I times V equation, and first having you figure out what the voltage is for each resistor, we're just going to say that the power is I squared times R. In essence, what we've done is we've combined the power equation with Ohm's law to eliminate the voltage. So my 6 ohm resistor, the power would be 0.5 amperes squared times 6, which is 1.5 watts. For the 12 ohm resistor, it will be twice as much, so it will be 3 watts. So if these were light bulbs, the one on the right would be brighter because it's exerting more power. It's dissipating more energy as heat. So to summarize, when resistors are in series, they have to have the same current, and so use the equivalent resistance in Ohm's law, and then use the shortcut P equals I squared R to figure out how much power they're exerting. The other way to connect two light bulbs or resistors in the same circuit is with a parallel circuit. In a parallel circuit, the resistors have independent currents, but they have the same voltage. Will be equal to the voltage of the battery. So an example would look like this. The blue wires show a light bulb being connected to a battery in a complete circuit. The red wires show that separate loop, which is also a complete circuit. Two ways you could draw a circuit diagram for this. One like that. Again, notice that there's two loops. Or like this. Again, note that there's two separate loops going through the blue wires and then through the first resistor and then back to the blue wires, or from the battery through the blue wires to the red wires through the resistor, through the other red wire to the blue wires and back to the battery. So there's two separate paths in a parallel circuit. Again, they have the same voltage but different currents. If you were to be asked to find the equivalent resistance, we use a reciprocal rule, where 1 over the equivalent resistance is equal to 1 over R1, plus 1 over R2, plus 1 over R3, yada yada yada, however many resistors you have. So for example, a 6 ohm resistor and a 12 ohm resistor is equivalent to 1 4 ohm resistors. Now how did I get 4 ohms? Well, do the reciprocals, 1 over 6 plus 1 over 12. Remember, when you add fractions, you need a common denominator. And so I would have 1 over 12 and 2 over 12. Remember your 4th grade math, which gives you 3 over 12. And then to get the final answer, I need to flip the fraction, do the reciprocal. And so the equivalent resistance is 12 over 3, which is 4. Notice that the equivalent resistance is smaller. It's because there's more paths for charges to follow. They're going to have an easier time moving around the circuit. When we add resistors in parallel, they do not affect each other. So if you have more expensive Christmas lights where one broken bulb doesn't make the rest of them go out, then those light bulbs were connected in a parallel circuit. When you add resistors in parallel, it decreases the equivalent resistance, which causes the total current to increase. This is kind of backwards from what a series circuit did. When you add more resistors in parallel, you're creating more loops, and so more charges can move around. So for example, find the current through each resistor in this circuit. Got a 12 volt battery connected to a 3 ohm resistor and a 6 ohm resistor in parallel. Each one has an independent current, so I'm going to calculate them independently. So for the 3 ohm resistor, I'm going to do Ohm's law, I equals V over R. The R that I'm going to use is 3 ohms, just the resistance of the battery. And I'm going to use the battery voltage as my V. So 12 volts over 3 ohms would give us 4 amperes of current. I'm going to draw that over there on the diagram. For the 6 ohm resistor, I do the same thing. Ohm's law, V over R. 12 volts is the battery. This time I use the 6 ohm resistor. And so that current is 2 amperes. Notice it's smaller because the 6 ohm resistor had a higher resistance than the 3 ohm resistor. To find the total current, simply add those two up. So the battery has to produce 6 amperes of current in order to make this circuit run. Kind of think of it this way. If I were to redraw the circuit and I were to put 3 different ammeters into the circuit at the 3 different locations I've just drawn there, they're each going to have a different reading. Number 1 is going to read 6 amperes. Number 2 is going to read 4 amperes, and the third one will only read 2 amperes. So it's important to remember when we have different branches, we're going to have different currents. To kind of illustrate that, let's draw a simple picture where we think of the wires as being pipes and think of the charges as being water and kind of trace how they move through the circuit. For a series circuit, it will look something like this. Notice you have the same number of charges in each little section of the wire. And since they're in series, they have to be the same current. If they were in parallel, which will look something like this, then the charges have two paths to follow. So notice that in the section of the wire where both currents are traveling, you have much more, or many more dots than you do when the current splits between the two. You get more current because you have more paths in a parallel circuit. Also notice that if you were to accidentally break that resistor, the other one would not be affected. You would still have a complete circuit. That's not the case for a series circuit. Breaking one would cause all the other ones to be broken as well. Last little tidbit, a voltmeter is always placed in parallel, and ammeters are always placed in series with each other. That explains how we had to build our circuits in all the labs we've done previous to this. You should now begin working on the series and parallel circuit assignment in your packet. If you have any questions, as always, please let me know.